Today is April 23rd, 2025. Today what we did was minimum spanning tree Kristal problem. So what we should do is using in ink matrix, which is incident matrix, it will make graph this from 0 to 1 and 0 to 2, 1 to 2, 1 to 3, 2 to 3 connected with weighted. Kristal algorithm's important thing is first, it will sort the graph by weight. And second, what it is doing is this is based on edge. So sort the edge on graph by weight and checking the edge one by one. And if edge have different parent, then it will, if edge have different parent, it will first make it to disjoint. We say disjoint them to one set, one parent, and then push it to, let's say, this time I make minimum spanning tree list. So this time we will return the list, and we will check again another edge one by one. And if it is same or not, we will check it. Because we are checking the minimum weight, for probably the lists that we will return will be minimum. Well, I'm also curious, is it really minimum? But let's go. This is what I understand. So this is int matrix. When we first just run the code, then it will give the matrix -1, -1, 0, 0, 0, 1, 0, -1, -1, 0, 0, 1, 1, 0, -1, 0, 0, 0, 1, 1, because how we saw it in the because we put the 5 edges. And for instant matrix, how you can read is there will be 4 rows and 5 columns. Each of the rows will be the vertices. So first column is first edge, so it is -1, 1, which means connected from 0 to 1. But in this case, it's not really important because we assume that in this problem, we assume that this is undirected graph, but this is just ink matrix, so it just gives such output. Weight, and also the current edge index. So what they are doing is returning the edges. And they basically implement graph edge. Edge is comparable. So our first step was comparing, and there's comparable method compareTo, so we can easily compare between each edges. And for disjointing the algorithm, we are using this one, which is making int parent. What it works is, if you see here, that it is just making parent and rank list. And for parent list, it will be, currently it is 4 because there is 4 vertices. There is 4 vertices, so rank is 4. Vertices. And find algorithm is checking each algorithm's parent. So whether it is same or not. So if you see the picture here, what they are doing is first making the lift, and when firstly making the lift, each of the nodes parent are each of them there's 0 vertices parent will be 0 and vertex 1's parent will be 1. So if we go to the matrix here, and what we're doing is this class is making matrix will be, this is the matrix part. m.length will be 4 in this case because there is 4 vertices, and m.numVertices that length will be 5 because there is 5 edges. 5 columns. So yeah, when you add edge, -1, 1 will be print out. And there's also method that makes it to string come out. And there is DFS and BFS. I can try it next time. So if you see here, get edges, what that get edges doing is for current edge index, and for metrics, that length, in this case, m.length will be 4, would be 4. So for each of the vertices, if some part is -1, then it gives -1, and it gives 1. So it is adding edges. What it is doing is adding actually edges. And we are doing now Kristal MFT here. We need to return the edge. We will make this one, and we will make disjoint set. What we need is number of vertices, and for each of number of vertices, we make disjoint set, and we bring edges here. And for edges, we sorted here. Then there will be each of the edges from 0 to 1, 1,0, from 0 to 2, 3,0, and there will be 5 edges will be sorted. Then now what we should do is for each edges, we can do our for using indexes, but we just do it like this. For each edges, if we check the edges, each of the vertex, head vertex and tail vertex, if they are different, then their parent is different, so we can add it. And we will also union them. So we unioned it so their parent is now same. And after that removing, then we can return it. So if I do one more clarification, it is the graph, how it looks like. Then this is the incident matrix. There will be -1, -1, 0, 0, 0, and blah, blah, -1 to 1. Then it means from each of edges, vertex 0 and 1 is connected. And if we first sort it, then it will return 0 to 1, 1,0, this list. Then with list list, we are using that compareTo method, making first each of the parent, and if they are different, we can remove their parent and connect each of the parent to the parent who have small weight. So this was what we basically did today. We can also extend it to how it really the rank list is worked, or how the dot compareTo is work. We will see those things next time. And thank you.